iPhone? Samsung? Oh, iPhone, oh yeah. You know, it doesn't. Okay.
Is it a tutorial tutor or new topic?
The first class is a new topic, and then the second class can be a tutorial then. Yeah. Okay. Okay. So we're going to have a look at surds. So when I say surd, I mean numbers like this. This is what I mean. Okay, so you should write this word down. My Brazilian student, would you call these surds or would you call them radicals? Or radicals, yes, yes. Yes, that's right. So we say surds here, but I know North and South America it would be radicals. Yeah. Okay, so that is a surd, A plus B root C. So what we're going to have a look at first, for example, is you want to simplify something like this. Okay. Let me show you something that you might find useful to help you simplify in this. So you learned this in elementary school, in fact. It's called prime factorization. And I'll show you it now. And I'm sure as soon as I show you, you'll remember learning this in elementary school, actually. So for example, if you have something like 70, you can say 70 is 35 multiplied 2, yeah, and 35 is 7 multiplied 5. So at the ends, you have 2, 5, and 7. So you can say 70 is 2 multiplied 5 multiplied 7. Now do you remember the words we did last time? These are called, do you remember? Factors. Yeah. So this is useful for these problems. This is called prime factorization. These numbers here, 2, 5, 7, these are called prime numbers. The prime numbers are 2, 3, 5, 7, 11, 13. You know these numbers? Yeah. What's the next one? No. What is it? 17? 19?
21.
Nope.
23.
23? 29? And so on. Yes. Okay. Right. Did you write this down? You got this? Do you remember doing this in elementary school?
Yeah.
I remember doing it in elementary school. Do you remember? No? No. Middle school? Or is this new?
Primary.
Yeah, primary school. You remember this too, yeah?
We use it like a different way. Just dot the line like this.
Ah, okay. I haven't seen that. It does the same thing though.
Yeah.
Yeah. Yeah, did you learn it in elementary school or middle school?
Elementary school.
Yeah. Okay, we'll go back to the example now. Sorry, do you have this? Yeah. The words are important, okay? So this is a new word, prime. Okay. Um, right. So, what you do, you ready? Yeah? What you do is you take your 108, so we could say that is 2 and 54. So this is a prime number, isn't it?
Yeah.
So we stop. 54 could be 2 and 27. So this is prime, so we stop. 27 is 3 and 9, isn't it? Yeah. And 9 is 3 and 3. So what you do is you change this root 108 into 2, 2, 3, 3, 3. Okay. And what you need to do is you need to group them in pairs if you can. So you have 2 of them here, which is good, and 2 of them here, which is good. So this would be square root 4, yeah, and then square root 9 and square root 3. So you put the root, I mean you could put the root over each one, root 2, root 2, root 3, root 3, root 3, but that's not helpful. So what you do is you put the root over pairs if you can, because root 4 is 2, so this is a 2, root 9 is 3, and root 3 is root 3. So 2 times 3? 6. So this will be 6 root 3. And this is the simplest you can make it. 6 root 3. Yeah. Do you want another example? Yeah. Okay, so write this one down and we'll do another one. Where's my coffee? I need it. Oh, have I drank it all? I know. Rats. Alright. Okay, write this down, we'll do another example. You got it? Not yet? It's okay? Yeah, okay. So let's do, for example, root 245. Alright. 245. That's going to be 3, isn't it? No, not 3. 5 and 49. So 5 is prime, we stop. 49? 7 and 7. I want English.
7.
Yes? Root? Yeah, root. You know this word? Root, sorry, I didn't say it. Root is this. Yes, okay. Right, so this is root 5, 7, 7, which is root 5, root, and you can put these together, 49. So yeah, that's 7 root 5. Yeah. Okay, I think we got the idea for this. Let's go on to a different type now. So next.
Can you go back?
Oh, you need to write it down? Yeah. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We have everybody. Yeah. Okay, got it now? Yeah. Alright, so the next type we want to do is, suppose I ask you to do something like this. Root 624 plus root 39. So in fact, it's like the last question, you need to do the tree, the prime factorization on both of these numbers. So let's see, 624, that would be 3 and 28. No, 280. Yes. No, 208.
No,
208. 208. Yeah. Okay, that's 3. This would be 2 and 104. This one we could actually do as 4 and 21. And 4 is 2 and 2, and 21 is 3 and 7. Right, so these are all my prime numbers. So this would be, you can put them together as root 2 by 2, so that's a 2 squared if you want to write it like this. So we've done that one and that one. Do I have any more 2's? Just this one. But I have 3 and 3, so that's 3 squared. I still have this 2, and then I still have this 7. 39, 3 and... Alright, so then we stop. So this one here is 3, 13. So there's nothing there. There's nothing there. So this one here would be 2 times 3 root 2 and a root 7. And this one here is a root 3 and a root 13.
There's something wrong?
Yeah, something is
in
wrong.
the first one, because 39 is...
No, 39 is 3 times 13, isn't it? Yeah.
So
Yeah, but I do feel like something did go wrong.
Yeah, there is just...
Maybe it's here. Let's check. 3 by 208, yeah? This one's right? Yes? Yeah. 208 is 2 and 104. Yeah. And no! Here's the problem here. It's not 21. 26. I'll do it in red. This is a 26 here. I'll get my pen back.
Because the comment must be like 30.
Yeah, so you can put them together. Let me just get pen. Okay. So in red, let me fix that. So that should have been 26. So that is 2 and 13. That's better. So now actually we have an extra 2 that could have gone here, and it's not 7, it should have been 13. Okay. So that's great because it's not a root 2. What should be here? Just 2. Alright. Yeah, so 2 by 3 is 6, by 2 is 12. Huh?
That's a 1 3.
Oh, thank you. So that's gone, and this goes back to being a root, like this. Yes. So this is 4 root 3 root 13, and this is root 3 root 13. And when I add them together, 5, and root 3 and root 13, I'll just write it as root 39. There's no difference, there's no point. I'll do another one of these. Okay, so write this one down. Yep.
Yeah.
Okay, another example? Yeah. So, next example is very similar again. So this time it's root 500 over root 20. Yeah, so I would like you, this is just one way to do it, but I'd like you to simplify the 500 and the 20. So 500, 5 and 100. 100, 10 and 10. 10 is 2, 5, 2, 5. So that means root 500 would equal, let's see, root that and that makes a 2 squared. That and that makes a 5 squared. And that is just a 5. So that'd be 10 root 5.
I have
10 root 5 for this part.
it's final is 5.
Oh yeah, I'm not there yet. 20 is 2 by 10, and 10 is 2 by 5. So you have 2, 2, and 5. So root 20 would equal, well, it'd be 2 root 5 when you do it.
So it's
So yeah, this original now becomes 10 root 5 divided by 2 root 5. So this is great because you can clearly see these cancel, and then 10 divided by 2, so the answer is 5. Yeah? Okay, next type. Sorry, can I go down? Yeah? Yeah, okay. 8 minus 9 root 21 minus 7 plus 2 root 21. Okay, so we multiply them. We do 8 multiply minus 7, 8 multiply this one, and then we do this one multiply this, and then this one here multiply this. So like normal. So this one would be 8 multiply minus 7, and then the next one plus 8 multiply 2 root 21 plus minus 9 root 21 multiply minus 7 plus minus 9 root 21 multiply by 2. Uh-oh, let me move a bit to the left. 2 root 21. So there's 2 here which are easy. This one is easy. Well, this one is the easiest one actually. And in fact this one is easy as well because these are the same. It makes it easy. But anyways, let's go through it one by one. So 8 multiply minus 7, minus 56. And then 8 multiply 2 is 16 root 21. And then here minus 9 multiply minus 7 is plus 63 root 21. And then here minus 9 multiply 2 is minus 18. And root 21 multiply root 21
it's 21.
21. Yeah. So this here now will be minus 56 minus 18 times 21. And then these two you can add together. So that would be plus 79 root 21. Does anybody have this for me?
400
This part?
yeah.
Yeah. Minus 56 minus...
78.
Yes. Plus 79 root 21. Minus plus 79 root 21. Now, in this case, I'm finished, but sometimes you could simplify this part more. But here, when we look at 21, what is it? 3 and 7, so there's no point. There's no point. So we can just leave the answer like this. Okay, write this one down, please. Sorry. Yeah. do another example of this one. Okay, you got this? Not yet? Okay. Not yet? Yeah?
Yeah.
Yeah? Okay. So let's have a look at something maybe a little simpler. Come on. There we go. 2 root 105 minus 3 plus root 105. So that's a little bit easier. There's just 2 multiplications to do. So we can do this one by this one. That would be minus 6 root 105. And then this one by this one here. That'd be plus 2. And then root 105 by root 105 is 105. So this is 210 minus 6 root 105. But the difference is, I think maybe we can do something with this. So 105 is 26 by 5. 26.
No. 25. 5, 6 is 0.
Oh yeah, that's true.
Yeah.
Sorry, 21. 21.
Yeah.
Not 26. Not 25 either. 21. 21 by 5. That's okay. It's a long day. It's a long day. Right. 5 we're done. 21, 3 and 7. So there isn't anything here. There's nothing here. Because this would just be root 3, root 5, root 7. So actually it's finished already. Alright, so this is the answer then. Okay, so the last type to do is dividing. So we've done simplifying and multiplying, so now we'll do dividing. Can I go down?
No.
Yeah, not yet? Okay, I can go down? Right, so let's have a look at something like this. Minus 10 plus root 147 divided by minus 2 plus root 3. So for these, the first thing I recommend doing is simplifying this part. 147 is 49 by 3. And 49 is 7 by 7. So it'll be 7 root 3. Because this would be root 7, 7, 3, which would be root 49 root 3, which is 7 root 3. So that's good. That's really good. 10 plus 7 root 3 divided by minus 2 plus root 3. So this is a good start. But does anybody know what I would need to do next? Next step.
Excuse me?
Yeah, just a sec. Just a sec. Question first, yeah? Question? Oh, you have the answer?
Yeah.
Oh, okay, alright. I thought it was a question, right. So you think you know, someone else knows? Yeah? Okay, why don't you tell me then? Yeah?
Like you have to minus 10 multiplied by minus 2 plus 3 root 3. I'd like
Maybe. What do you say? Multiply by minus 2.
Minus 2.
Like
Okay.
you minus 2 plus root 3.
Yeah.
You want to get out this.
Yes, I do.
So I don't know what you call the first part.
Oh yeah, sorry. I should give you some vocabulary to help you here. So this here is called a fraction. Okay. So the top. Does anyone know the name of the top and the bottom? Is what?
It's on the top.
The bottom is denominator, and the top is numerator. Definitely write these words down. Numerator, denominator. Numerator and denominator. Okay. Numerator, denominator. Yeah. Okay, you got this? Yeah. Right, so, Salik? What's it?
Yeah.
Yeah. Maybe with these words you can explain now. So what do I do next?
Minus 10 multiplied by the denominator
Yeah, go on.
over the denominator
Yeah,
uh,
maybe.
squared.
I think I know what you're trying to say, but not this. So you're thinking, yeah, I know what you're saying. You're thinking put this here, and then put it here as well. So on the bottom it's a square when you multiply them. Yeah. So it's almost this, but it's not quite this. You think you know?
It's like 1
Yeah.
1 minus 2 plus root 3
Yeah.
over minus 2 plus over 3 multiplied
Yes. You're so close, but it's not quite this. It's almost this. It's almost this. Yeah. Now you almost have it, but instead, hey, come on, listen. I had to look over 3 times now because the two of you are talking. So please don't make it a 4th time, or you'll go. Okay, so you almost had it, but somebody remembered that for these problems, you multiply by this. Now the point you were making was this is like 1. It is. But the only difference is we put the minus here instead of the plus. The sign, yeah. Now, the reason is, it will be clear in a moment, but just so you have more vocabulary, this is called the conjugate. So when you change this to a minus, it's called the conjugate. Similar word as in Portuguese, is it? What's it in Portuguese? Yes, practically the same. Yeah. And I'm sure numerator and denominator are the same nearly, yes? Yes, yes. Okay, just to practice some conjugates for a moment. So for example, if I had 3 plus root 2, the conjugate would be 3 minus root 2. If I had root 3 plus 4, the conjugate, minus root 3 plus 5, sorry. The minus goes here. If I had root 3, the conjugate be minus root 3. Yeah, so in other words, you changed only the root. Okay. Right, so we'll go back to the question. So now we have to multiply the top, which is minus 10 plus 7 root 3. Needs to multiply by minus 2 minus root 3. Minus 2 plus root 3 minus 2 minus root 3. Now, we'll see what happens now with the denominator. Okay, so let's multiply the top. So that would be 20 plus 10 root 3 minus 14 root 3 minus 21. And on the bottom, that would be 4 plus 2 root 3 minus 2 root 3, and at the end, minus 3. Now look what happens in the middle.
No root.
Yeah. So this is why we use the conjugate, to cancel this part. Okay, so on the top, we have minus 1 minus 4 root 3, and on the bottom, 1. So this would be minus 1 over 1 minus 4 over 1 root 3. So the answer is minus 1 minus 4 root 3. So this is the answer here. Okay, so we'll do one more example and then I'll give you the questions. You have this? So just so you know, this process here, its name is called, it's quite long, it's called rationalizing the denominator. So rationalizing the denominator means multiplying by the conjugate. Sorry, yeah, it's actually in the question 4 if you want to write it down. Yes. Yes. But you need to know it for the exam. Okay, can I do the next example? I'll just write it down. Minus 63 plus root 504 all over minus 7 minus root 14. Okay. So let's have a look here. The 14 will just be 2 and 7. So nothing there. Maybe we can do something with the 504. 504. 99 by, no, not 99 by 5, not by 5, by 4. 129 by 4, is it?
9 by
126, 126 by 4. I could do it this way, couldn't I? No, I couldn't. 120, yeah, 126, isn't it? Yeah, okay, yeah, all right. 4 is 2 by 2, so we're finished. This is definitely a tray and 42, so that's finished. 42 is a tree again.
6 root 14.
Oh, we'll do it the slow way. 14, yes, and 14 is 2 and 7. Okay, so we have here, oops, root 2 squared, root 3 squared, there's another 2 and there's another 7. So as you said, it'll be 6 root 14. Isn't that what you said? 6 root 14, yeah. So this is minus 63 plus 6 root 14 over minus 7 minus root 14. Now I think I need to remove, oh no I don't, okay. So the conjugate would be minus 7 plus root 14 and minus 7 plus root 14. So this will be now minus 63 plus 6 root 14 multiplied by minus 7 plus root 14 divide minus 7 minus root 14 minus 7 plus root 14. So let's see what we get on the top and on the bottom. Let me just remove this bit here, make some space. Okay, so on the top we have 421, isn't it? Is it? 421? No?
441.
441? 441. And then add 21, yeah. 441. And then next is minus 63 root 14, minus 42 root 14, plus 6 multiplied 14, which is 60 and 84? Okay, and then down below is 49 plus 7 root 14. No, hang on. No, sorry. I'm doing it wrong. Minus 7 root 14 plus 7 root 14 minus 14. 4, 4, 1 and 84. So that's 525? Yeah. 525 minus 105 root 14 all over 35 equals 525 over 35 minus 105 over 35 root 14. Now I can divide by 5. So the first one is 15. Is that what you're saying?
Yeah.
Exactly 15? No, 15 over 7. No? If I can put a 5 here to make 7, and I can put a 5 here to make 105. And then 7 can go into this 15 times. So it is, okay, so it's 15, that's great. So 15 minus 7 root 14. Don't believe it.
It's 3. Not 7.
Oh yeah. Yeah. Of course. 3, not 7. Minus 3 root 14. Now that seems better. So I did correct. Okay. Do you want me to mark the questions?
What's the big?
Yeah, so page 10. Okay, so in number 1, Y and Z. Number 2, yeah, Y and Z. Y and Z and X and Y. 2. Last 2 in each. Yeah?
So we use X, Y.
No. YZ, 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 XY. There is no Z. Okay, so you can start them now for a couple of minutes, and then we can do a tutorial in the next class.